So hey guys, welcome back to another lecture. So in our previous lecture, we have seen the mean, median and more. So today we're going to discuss some of the most interesting topics in the probability. We are getting into the real probability from now, from the last lecture, from the previous lecture. So quantiles. So what do you mean by this quantiles? So like a quartile is where a sample is divided into equal sized subgroups. It can also refer to the dividing a probability distribution into area of equal probability. Means like a quantile means like if we have a data set and this quantile divides into equal sized subgroups here, means like the quantile is dividing these equal sized subgroups. Are you getting it? So like the quantiles are dividing the data into equal subgroups, and it can also refers to the means like if you have a probability distribution, there also it can divide the data into equal subgroups. So we have a percentiles, we have a quartiles, and we have a deciles here. So in quantiles we have a percentiles, quartiles, and deciles. So what are these percentiles? The percentiles means like it divides the distribution into 100 equal parts. Percentiles means like it divides the distribution. This is a distribution and it divides into 100 parts here, 100 parts here, and this is percentile, and this is a quartiles. So this is the main thing here. So we used to most so we used to do the most of the time, which is quartiles here. It divides the distribution into four equal parts like this, 1 2 3 4. Okay, 1 2 3 4. And after that we have a deciles. So like what do you mean by these deciles? Means like it divides the distribution into 10 equal parts, 10 equal parts. So I hope you get these three. Like, so percentiles means like it divides into 100, and quartiles means like 4, and deciles means like 10. This is 4. Means like I hope you have a basic intuition. So like so let's get in these quartiles. Okay, so like what are these quartiles? Quartiles means like divide the entire data set into four equal parts, right? As I said, na, four equal parts here, 1 2 3 4. And there are three quartiles, which is q1, q2, and q3. So like if we have a distribution like this, I'm so sorry, if we have a distribution like this, and these are the lines. These are the q1, this is the q1, this is the q2, and this is the q3 here. So it divides the distribution into four equal parts here, four equal parts, 1 2 3 4 here. Okay, so like what are the steps to follow this quartiles? So first we put a data into order. The order is important here. We have seen in the median also, it has to be order. So otherwise it's very difficult to have a distribution like that. And we cut the data, means like we cut the distribution into four equal parts. Here we cutting the distribution into four equal parts. This is the one part, this is the second part, this is the third part, and this is the fourth part, right? So like three quartiles are cut the data. These are the three quartiles, 1 2 3 here. So like we have a this, right? So I just draw there this q1, q2, q3, and we have a p1 here, part 1, part 2, part 3, and part 4 here. So here we have a part 1, part 2, part 3, part 4. So we have divided these distribution into four parts here. So for example, we have a data like this, 2 4 5 6 7 8 9, and if you do the quartiles here, and this is going to divide four equal parts, four equal parts, and this is a first, the q1 is a lower quartile, and the q2, which is a middle quartile, and the q3, which is the upper quartile. I hope you have a basic understanding. So in a geometric view, I have shown this, but this is a better diagram, better than that. So we have a distribution over here, and the quartile divides the distribution into four equal parts. Part 4, these are the four equal parts, which is around like a 25%, 25%, 25%, and 25%, 100% total, right? So like how this gonna tell like, so we in that quartiles we have a interquartile range, like, so we have a q1, q2 and q3 here. So in this quartile and we have a interquartile range. So like, what is the interquartile range? So it is a range from q1 to q3. So this is a range from the q1 to q3. So where the most of the data is present. So here you can see the most of the data present here only, right? So the most of the data present here, not in the sides of the corners, because the most of the data is present here, almost like a, it depends, almost the data is present here, right? So like, if we have a 25%, 25%, 25%, 25 means like the distribution divide equal parts, like, so how we gonna find this interquartile range? So we just simply subtract this, means like we just simply subtract this q1 from q3, which is means q3 minus q1, right? So if we have this 3 and if we have 1, then we simply do 3 minus 1, which is equal to 2. I hope you are having basic intuition. So in a geometric view, so this is a distribution, and if you run this q3 minus q1, and then we're gonna have only this remaining thing. This is our IQR, which is interquartile range, which is q3 minus q1. So like, how we gonna interpret this quartiles? So like, this is a score of a 19 students over there. So we have a 50, 60, and this is a score of a 19 students in a classroom in a mathematics exam, and these are the scores for that. And we have applied the quartiles here. This is a quartile 1, this is a quartile 2, this is a quartile 3, and we have divided these four equal parts here. So like, the q1, it is a central part between the q1, which is, it is a central part between the this beginning of the smallest and this q2 median, right? So like, how we gonna find this? You by the eye you can understand, but if we have a data of 1 lakh, then it will be really hard for me, right? So how we gonna find it? Quartile means what? With four equal parts, and we're gonna find the first part. So we're gonna simply, we have n means like 19 students here, and then we simply gonna multiply these with a quartile, which is 1 by 4, and then we simply get 4.75. So we're gonna take means like average value, approximate value. The 4.75 means approximately equal to 5. So we're gonna start with 1 2 3 4 5, and this is our q1. So same it goes to the q2 and q3. So like, this q2 is the median of the data. How are we going to find median? This is the second quartile, right? So we just simply multiply with the 2 by 4 here, which is n. This is 19, and we're going to get as a 9.5, and which is similarly equal to the 10. This is 5, right? 6 7 8 9 10 here. This is q2. I hope you're getting it. So after that, we have a q3 here. This is also similar. Like, I just want you to try it on your own, okay? So don't look at this, I just want you to try it on your own. And after that, if you don't get, then please look into this, okay? So the q3 is the median between these, q2 and this largest number, right? We have the data in ascending order. We have data in order, not in a random way. So if it has a random way, it's gonna give like a wrong answers, okay? So you have to keep in mind, like, this, if you're finding the quartiles, the data must be ordered. Okay. So like, so the score of q1 represented the first quartile here, which is a 25%, right? So the q1, which is a 25% here, and represents the median of a lower half of a score set in available data, and the q1 tells the 25% of the score, which is 68%, right? So like, the 75% of the scores are greater than the q1. If it is 25%, and the remaining, which is 75%, means like the 75% of the students score more than the 68. I hope you're getting it. And the q2 tells the median, which is 50 percentile. Shows that 50% score means like there is a 50% students, like if you have 90, right? So what is the median, right? Which is 9.5, right? So which is 9.5 means like, if you have 90 students, 9 students scored below the 50, and 9 students above the 50%, In this example 75 means like nine students got below 75 marks, and 9 students got 75 above the 75 marks. Above the 75 marks. I hope you're getting it. And the Q3 tells you 75%, reveals that 25% are greater than the 87 and 75% less than the means like in the Q3 means like more than 75%, means like these are the brighter students brighter students here. So like I totally disagree with this, means like getting marks. So in this example I have to use, but I totally disagree this, because getting marks doesn't mean that you are knowledgeable, right? So I think it's a kind of a controversial topic, so as of now just leave that. Okay, so like what is IQR? We have seen that tells how far from one to second quartiles are. We have seen this Q3 minus Q1, how far these apart from the 1 and 3 quartiles are, and indicating how spread out the data 50% of in distribution. We have seen this Q3 and Q1. This is our the almost 50% of the distribution. In the IQR in resistant to the outliers, means like we are, the most of the data lies here, so it is good, it is resistant to the outliers here. So we just simply, if we ignore this also, we gonna most of the data lies here, right? So these are the resistance to the outliers, and it helps to measuring the outliers. We can measure these outliers also. We have this Q1, before the Q1 we have another part here, after the Q3 we have part 4 here. So we're gonna find the outliers also. It's help to measuring the outliers also. So for example, we have taken the small data, it's a small data like 2 3 3 4 5 6 6 and 8 8 and etc, 8 8 9 and etc. So the what is the Q1 here? If we simply divide this into 4 parts here, this is a Q1 which is 3.5 here, this is Q2 which is 6 here, and the Q3 which is 8 here, right? So we're gonna find these Q1, Q2 and Q3, and I'm gonna find the IQR, which is a interquartile range, which is Q3 minus Q1, which is almost equal to, so we have taken the approximate value which is 4 here, right? So which is 4 here, so the IQR is 4 here, and the R is 9 minus 2 here. From the Q4 means like from the highest value to the lowest, which is 9 minus 2, which is equal to the 7. The range is 7 here. So if the data has 100, then the range is R is equal to the 100 minus 2. Means like if we having the range, right? So this is the highest minus the lowest. This is called as range. If we have 100, then 100 minus 2, which is equal to the 98 here. So IQR is best while dealing with the outliers. As I said, it's very good in the outliers, because the outliers, most of the data we say into Q3 and we just simply ignore these outliers. So it is good with the dealing with these outliers, and it identifies the outliers so that we can remove the outliers. We can identify these outliers, so we can simply remove that. So after that after finishing that, we have a percentiles. So what do you mean by these percentiles? We have done the great detail talk on quartiles, and after that we have a percentiles. So what do you mean by these percentiles? Percentiles of scores fall below that number, means like the certain percent of scores fall below that number, means like 90 students fall between this 90%, right? So I just want to give, so if you know that your score is in the 90 percentile, that means like you scored better than 90% of the people who took the test. So if you score, if your percentile is 90 percentile or 92 percentile, means like you have scored 92 percentile best. This means like you scored better than the 92% of the students who took the test, right? So the 25th percentile means the first quartile, and the 50th percentile means the second quartile. We have seen this in a quartile lecture, in a quartiles, right? So in the 75th percentile, which is the third quartile. So and the difference between these third and first is a IQR, right? So like how we gonna find this percentile rank? So in the above example, 90th percentile. So we have a 90th percentile here, and the 90 is the percentile rank. If we have a 92 percentile, I just want to find the 92 percentile, and the 92 is the rank of that percentile, right? So like we have discussed, so after percentile we have a decile. So like what do you mean by this decile? So it divides the data into 10 equal parts. As I said from in the beginning of the lecture, it divides the data into it divides the distribution into 10 equal parts. So like if we have a sample data here, we have a sample data here, and this gonna divide this 10 equal parts. So these are the numbers, so it will be easy for you. If the data is like a 1 lakh, 1 lakh, 1 lakh, then it will be really hard, but this gonna divide like 10,000, 10,000, 10,000, 10,000, like etc. They want to divide that 10 equal parts. Okay, so the first decile is 2 here, which is 10%. This is 4, which is 40%, and the 6 is 80, and which is 60% here. 6th decile. Okay, and we have a 10th decile, 9th decile, which is 10, which is 90 percentile. Means like the 90% of the people, the 90% of the students are scored. Means like these are not the scores. Okay, so if you take this as a kind of examples, like these are the kind of credits, for example. Okay, so the 90% of the students are below this one number, right? So I hope you have a basic intuition like what are these what are these what are these quartiles, what are these quartiles. In quartiles we have discussed percentiles and quartiles and deciles. This is a quantiles. There is a difference between these quantiles and quartiles. Quantiles means like it's just dividing the equal parts. In that equal parts we have a percentiles, we have a quartiles, and we have a deciles. It divides into 100 equal parts, it divides into 4 equal parts, and this is divides into 10 equal parts. So I hope you understand these, what are these terminology. In our next lecture we're going to cover the variance. So like we're going to cover what is variance and what is exception, and we have a great detailed talk over there. So we have a great lectures coming up. So I hope you love this lecture. So until then, bye bye. See you in the next lecture. I hope you love this lecture. So if yes, then please subscribe and share you with your friends. I hope you do that. Thank you.